All right. Welcome, everybody. Come into our virtual co-opting AI space for a new episode looking at the intersection of artificial intelligence and society. Make yourself comfortable. We have a very exciting conversation on the docket for you today. My name is Mona Sloan. I am a sociologist by training. I'm the host of the Co-opting AI series. I'm based at the University of Virginia, where I'm a professor of data science and media studies. I am very lucky in that the Co-opting AI series continues to be generously supported by the NYU Institute of Public Knowledge and our home here at UVA, the UVA Karsh Institute of Democracy. And as always, a heartfelt thanks to the teams in both places for making these conversations possible. Now, before I start our conversation today and set the scene for you, I want to acknowledge that the land where we at UVA learn and work is the homeland and traditional territory of the Monacan Indian Nation. We pay respect to their elders and knowledge keepers, past and present. We also acknowledge and pay respect to the enslaved Africans, enslaved laborers, and free Black laborers who built UVA, as well as their descendants. Today, we acknowledge the land, we acknowledge labor, tradition, and knowledge, and we acknowledge lives. Now, in recent years, we have heard scholars and folks who work on establishing accountable and fair AI talk about AI as socio-technical systems. That term is used to underscore that all AI ultimately is social. And as a sociologist, I subscribe to that. Ultimately, without people, there is no technology. Using technology to organize society, of course, is a social effort too. And it is an effort in creating social hierarchies. Over the course of history, technology and mathematical systems have sort of co-evolved with attempts to sort people into hierarchies. Here, in that context, measuring people's anatomical features, which is also called anthropometry, that has always been key, particularly what is called craniology, which is the measurement of the human skull. In the last few hundred years, craniological methods, for example, measuring the angle of the face, the size of the brain case, or the ratio of the length to the breadth of the head, have been used to classify people into racial groupings, to make claims about alleged differences in intelligence, and to study human variations. Now, today, AI systems that allege to, for example, infer sexual orientation or criminal leanings from facial features are not far removed from those efforts. So there seem to be interesting and deeply problematic links between AI and the human anatomy. And that is what we're looking at today. We're looking at AI and anatomy. But we also want to start off with the idea that there are AI systems that can perhaps make meaningful contributions to the study of anatomy and the teaching thereof. So in the educational context. Now, these may shore up old and new questions in bioethics as well. So clearly, anatomy is a rather productive frame to explore the thorny intersections of AI and society. And I'm fairly certain that my three terrific guests today will help us explore these intersections. It is my absolute pleasure to welcome today's co-opting AI panel on anatomy, Tom Champney, Rachel Prentice, and Jackie Vernemont. Now, kicking us off today will be Tom, who is a professor of cell biology and anatomy at the University of Miami. He teaches first-year medical students gross anatomy, histology, and neuroanatomy, and he also coordinates the South Florida Wilt Body Program for the State Anatomical Board. In addition, he is on the university's ethics program and helps teach the responsible conduct of research course, as well as teaching a graduate level research ethics course. He is very busy talking to the press about all kinds of questions on bodies and ethics. He publishes commentaries on the ethical use of human tissues, notably the use of Wilt bodies, and is a member of the International Federation of Associations of Anatomists and the Medical Humanities and Ethics group. He earned his PhD in biomedical research at the University of Texas, Health Science Center at San Antonio, and has held positions at the University of Delaware, Texas A&M University, St. George's University, and over in Switzerland at the University of Zurich. Thank you for joining us, Tom. Great to have you. Then, following Tom will be Rachel Prentice, who is an anthropologist of medicine, technology, and the body. Her interests focus on opening up the assumptions and contradictions contained in 21st century North American biomedicine. Her recently completed project is an ethnographic examination of anatomy and survey teaching, and the rise of simulators and other technologies for teaching and practice. Professor Prentice documents how physicians in training come to embody biomedical techniques, perceptions, judgments, and ethics, learning deeply held medical values while learning to practice medicine. Thank you for joining us today, Rachel. It's great to have you. Closing us out today will be Jackie Vernemond, who is a distinguished professor in digital humanities and social engagement in the Film and Media Studies Department at Dartmouth College. She is a feminist, anti-racist digital media scholar who specializes in mathematical and computational media and their histories. She has a book out called Numbered Lives, Life and Death in Quantum Media. That was 2019 with MIT, and another one called Bodies of Information out with the University of Minnesota Press. She's particularly interested in how quantum media render the complexity of human life and how knowledge and memory has been and can be cultivated outside of alphanumeric media. She also is busy writing outside of academic venues. She has written for Wired, The Atlantic, and Slate, as well as the Washington Post, and has engaged, of course, in academic publishing in several academic journals and has produced edited collection. She's trained in early modern history of science and literature and has expanded the range of her work to include contemporary quantum media and different modes of making data tactile and visceral, particularly working with sound and haptics to render data. Welcome, Jackie. It's so great to have you. Thank you all. All right, fantastic panel. You can see how we're so excited about a conversation about anatomy today. Also, a few words of housekeeping. We are going to hear the provocations from our panelists, and then we'll engage in a panel discussion. Meanwhile, you are encouraged and welcome to put your questions into the Q&A box at the bottom of your Zoom screen, and we will fold these into the conversation as we go along. And with that, I am going to shut up now and hand it over to Tom, who's going to take it away. Thank you all for joining.
Thank you very much, Mona. And I'm going to start to share my screen because all good lecturers have to use PowerPoints, right? I think it's in our contract. So I will share that with you all. Put this up here, on that. So here's my few PowerPoint slides. Thank you again for the introduction. Kind of the title of my talk is Artificial Intelligence and Anatomy. How important is the human element? And it's a thing that I would like to kind of emphasize is that we do talk a lot about all the things that artificial intelligence can do, but we don't necessarily talk about the things it can't do. And that's really the human element aspect, the human contact, the ability to interact, et cetera. So this is me. You can certainly contact me. You're welcome to email me, et cetera. I like to engage in post post-podcast conversations. You can see I'm smiling quite nicely here because I really like sailing. That's why I live in Miami. So a few publications, and I have a list of publications at the end, and I'm quite willing to share this PowerPoint with anyone too. If you email me, I can certainly share it with you. This was a very nice paper by Michelle Lazarus and her colleagues this past year about integrating AI into anatomy education. And she primarily made these 6 points. And I'm not going to spend a lot of time on them, but I think you should at least kind of think about them. And I think many people have. One, to increase the transparency of when we use AI, that we have plenty of diversity in developing of AI. We all know that algorithms that come from AI tend to have a bias to them, and trying to reduce that bias, especially in anatomy, which already has a bias to it. And we really need to try to expand out of that bias, both in normal anatomy, as well as any sort of AI-generated anatomy. And then the other component of uncertainty and variation. There's lots of variation that occurs in the human form and human anatomy, and that's difficult sometimes to incorporate into algorithms. For algorithms to understand that there is this wide range of variation, algorithms tend to point more towards the normal, try to normalize things, as opposed to allow for variation to occur. She mentions educator awareness about the use of AI, that there should be AI free time that takes place in the laboratory with donors, et cetera. That shouldn't get so wound up in the AI that AI becomes the only thing you're working with, et cetera. And then finally, this idea that AI can extend human capacity. The link for the article is at the bottom. The full link is on the references in the next few slides. And then a recent paper that John Cornwall, Sabine Hildebrandt, and I wrote really talked about whether you could bring artificial intelligence into the anatomy laboratory and where it would be helpful and where it might not be helpful. And I would say that the main takeaway that we think pointed out is that the donor that we use in the lab, this individual that we teach anatomy with, doesn't just teach us anatomy, but also teaches many human interaction components, i.e., understanding death and dying, understanding altruism, understanding how these individuals lived their lives and how lives were well lived. These are all things that could never be duplicated or simulated through an AI. The example I like to give is if, even the best AI, the super best developed AI, the student interacting with that AI is going to know that it is not real, and therefore will have a different relationship with that simulation than they would with an individual in the lab who they know lived, existed, maybe had children, had a life outside, brings a whole nother aspect to the educational environment that you cannot get with just AI. So that was basically what we did in our paper, and that link is down here at the bottom as well. I found this blog I thought was kind of nice by Shakik. It's all about how artificial intelligence is being used in medicine. And there's some really fun little pictures there. It's a fairly long blog, but it's a very nice development on where AI is being implemented in medicine, the value it might have, and some of the drawbacks that there might be there as well. So I, in essence, point that out just for people who might have an interest and might want to further investigate it. And these are, I guess, my takeaways. So this is kind of my takeaway slide. I think AI can be useful in anatomy education and in anatomy in general. And I think you can use it for grading, for editing PowerPoints or editing Word documents that you might be working, et cetera. And ways to enhance education. Some students really like movable AI, where you can swing things around and look in and out and have a virtual reality type of an experience. And that can also all be very valuable for enhancing of education. But I would say there are places where you need to and almost are required to continue to have human involvement. And that would be with the donors in the lab, learning from those individuals who have donated and the value that they provide, not just the anatomical value, but the professional value, the professionalism, those types of things that students can learn and can interact with. I do think, and it would be a great point for discussion, that I think the relationship between the educator and the student is also a human interaction. And you lose that if you start using computer simulations as your means for educational involvement. And then that extends, of course, to professionalism and to role modeling, something that we take very seriously. The way we act in the lab with the donors and with the students is ways we feel those students should act with their patients in the future. So we're setting the stage for them to understand the proper ways to interact with individuals, be they alive or deceased, right? How to discuss these issues, how to talk with their peers, right? There's lots of human interaction that can take place in the anatomy lab, in the teaching of anatomy, that I don't think can ever be duplicated, even with the best AI systems. So this is me again, just so people can understand it. I did want to mention, at least, I have to give a shout out to my colleagues, John Cornwall here and Sabine Hildebrandt. The three of us are what we call the bioethics unicorns, a term that was made up by John and has had a lot of cachet. I even made little cards out of it. You can see the cute little unicorn on the card here. If you ever meet me in person, happy to share some cards with you. These are collector's items. But the QR code or the link here will take you to a set of PowerPoint presentations and Bioethics Unicorns webinars that we have quarterly that we talk about ethics issues in anatomy. And many of these same topics, professionalism, how we deal with specific aspects of human tissue use in anatomy, et cetera. So I make that out there as a pitch for our Bioethics Unicorns. I have a mailing list. If you'd like to be added to the mailing list, please email me and I can put you on there. But also just to let you know that we are very involved and concerned with more than just teaching of body parts and learning of body parts. These are the references. And that is my 10 minutes. And as I said, happy to share any of these PowerPoints with you. And I think it's my time to pass it off to Rachel.
Okay, I'm also going to show some slides, so we'll start there. Oh, that's not going to work that way. Hang on. Minor technical difficulties here. All right. Now let's, anything else? Okay. That should work, but I can't do it. There we go. All right. So first of all, I would thank you, Tom, for the handoff, and thanks, Mona, for inviting me today. When I saw Mona's call to problematize AI's fascination with bodies, I really knew what I wanted to talk about. I wanted to go back to something that was something that stuck in my mind from my work studying tools for teaching anatomy and surgery that I'd never gotten a chance to look at. So, and I actually think Tom's title, How Important is the Human Element, might be thought of as a question that kind of haunts this particular provocation. So the provocation was supposed to be kind of a dystopian speculative fiction built on technologies and logics. But built on real existing technologies and logics. But the deeper I got into the topic, the more I realized that this isn't really particularly speculative. So what I describe is happening now, though there'll be a little bit of speculation at the end. And it's built on the idea that our minds and emotions are the last frontier of privacy. And it raises the question of how much of that do we want to give up? So this paper starts from the forms of behavioral surveillance conducted by companies like Google and Facebook, and described by sociologist Shoshana Zuboff in her masterwork, Surveillance Capitalism. Zuboff describes how our clicks, likes, searches, and other products of digital life provide companies with a huge store of data that can be mined to produce predictive algorithms that analyze or even influence our behaviors. And Zuboff writes, in this new logic, human experience is subjugated to surveillance capitalism's market mechanisms and reborn as behavior. And the connection to anatomy is this. AI technologies are now being developed to analyze our innermost states of emotion and regulation. Those technologies do not rely on statements about what our inner states are. So it's not reliant on people saying how they feel. Instead, they're using the body itself to analyze what's happening inside. And here's the part that is less speculative than I thought. As the logics of predictive analytics come together with these emotional analysis tools, our innermost beings, our souls, if you can allow me some literary license, are becoming fodder for the kinds of behavioral analysis, prediction, and modification that already use our preferences, experience, and desires as raw material for a vast capitalist project. But let me get a little more specific. This story begins in California in 2001. And as I was doing my dissertation fieldwork and looking into digital tools for teaching anatomy and surgery, I flipped through a whole bunch of papers from the Medicine Meets Virtual Reality Conference, which is an annual meeting for developers who are bringing together digital tools for medical teaching and practice. And one paper caught my eye. It was a conceptual paper by Norman Alessi and Milton Wong titled Digital Motion Phenomenology of Depression. Alessi is a psychologist, and Wong works on digital tools for psychology. They wanted to use motion capture technology to study the movements of depressed people. They contended that the psycho aspects of this psychomotor ailment had been heavily studied, but that the motor aspects of depression had been neglected. And psychologists have observed that the body slows down during a depressive episode, and that's apparently visible to the trained eye, but not so visible to the trained eye that you can characterize it without something like motion capture. So they proposed to use motion capture to characterize these episodes, to sort of break them down a little bit. And they hypothesized that depression might be a movement and not a mood disorder. So they argued that they also fantasized about developing a kind of objective test for depression, a test that they likened to an ECG or a blood test or something like that. And they hoped that the test could bypass patient statements about their inner state or practitioner judgments. And this move to create this objective measure really reflects an old push within the history of medicine to develop devices that move away from patient statements about their experience and away from clinicians' expert judgment, creating a kind of machine objectivity. And when I saw this paper, and I think that there were a couple of others, my suspicious mind kind of jumped to the idea that rather than a clinical tool, this could easily become a tool for employers to scan their employees' bodies and to determine who was likely to become a drain on corporate resources. Or possibly movement that didn't meet the objective measure for depression could mean denial of insurance claims. So if you didn't think, just to give you a sense of what the costs would be, depression costs employers an estimated $188 billion a year. And that figure includes $134 billion in healthcare costs, $21 billion for absenteeism, and $33 billion in lost productivity. So technology that could identify depressed employees from external behaviors likely would be welcome to the same kinds of employers who track clicks and monitor bathroom breaks and that sort of thing. Getting people treatment might be the utopian goal of this tracking, but getting them off somebody's insurance would be cheaper. So the motion capture really didn't get very far, not least because motion capture is kind of a clunky technology. But researchers are still seeking ways to analyze human movement to assess mental illness. So we jump forward 20 years, and we're actually deep into this world of behavioral analytics as pioneered by Google and others. AI tech is being adopted widely for mental health, in particular chatbots that are descendants of Joseph Weizenbaum's Rogerian therapist, ELIZA, are being adopted largely to provide cheaper therapy. The best titled of these is something called Woebot, which is a chatbot therapy program. And Woebot claims to do sentiment analysis. That's their term. And what the system does is examines text inputs for signs of sadness, loneliness, or despair. Woebot Health, which is the company that designed this thing, promises mental health at scale. Given the name, I couldn't help but thinking about Marvin, the depressed robot from Hitchhiker's Guide to the Galaxy, actually chatting with Woebot. But that's a different story. So Woebot's based on chat, but there are other programs that are based very specifically on the body. In particular, a program called Kintsugi, which does facial and voice analysis to, quote, give real-time emotional feedback to therapists. You could ask, why do they need that? The company claims that 60% of mental health patients are falling through the cracks, saying that their programs help. And if you find this kind of talk vague, that's because their website is all these vague promises. It's a little bit unclear what they're actually doing and who it's for. But the program I want to focus a little bit on briefly is an open source smartphone technology that captures facial data to identify markers of depression. FaceSci is a works in the background, and when a user interacts with his or her phone, it identifies markers of depression for analysis by researchers. The program marks things like dimpling, pulling up lip corners, depressing lip corners, etc. And the company's creators, Rahul Islam and Sangwon Bai, say, quote, "We've hypothesized that digital biomarkers extracted from facial cues offer valuable insights into an individual's internal, emotional, and affective state, thereby enabling algorithms to infer depression. So the body becomes effectively a window into the emotions." Face-size programmers note that psychologists have questioned whether negative facial expressions are indicative of depression. So the meanings of these behaviors is contested, especially the question of whether the frequency of positive versus negative facial expressions actually indicates depression. And no mention is made at all of cultural differences. So the assumption seems to be that the meanings of chin lifting or lip corner raising are bodily universals. But FaceSight right now is a research tool. It's designed to actually capture this like sort of facial expressions in the wild. And the programmers have set it up to delete the facial data from the phone as soon as it's captured, saying that this is the key to keeping the data private. But as Donna Haraway says in her Cyborg Manifesto, quote, "Illegitimate offspring are often exceedingly unfaithful to their origins." So here's where we come back to surveillance capitalism. Google already offers users a clinically validated patient health questionnaire. And depending on the user's answer, the system might tell the user to seek help. As one review article talking about AI and mental health argued, the integration into one of the world's most widely used search engines significantly increases the potential reach of mental health assessments. These Google services are free, but they're not without costs. Google relentlessly gathers user data to feed its analytic engines. So now we're back to the speculative part. How soon before facial analytics designed to capture your internal states get built into Google search engines or something like it? How soon before our innermost beings, the kinds of things we might choose not to share with others, even things we might not be aware of ourselves, become part of behavioral analysis and modification? And I would say that so many of our digital behaviors are already captured, analyzed, and monetized. Already a huge amount of our inner lives, at least the things we choose to explore through searches and whatnot, are captured as raw material to feed prediction machines. I think we ought to be aware that systems engineers are always looking for new ways to mine more data from our bodies and our beings. I think it's worth asking whether we're willing to give ourselves, our thoughts, our emotions, our states of being to this kind of machine intelligence and to this kind of behavior for sale. So what that will do for our sense of privacy is an important question. But as significantly, what will that do to our ideas about ourselves, our inner being, our emotions, the core parts of ourselves that we might not choose to share? And with that, I will pass this off to Jackie. It's going to take it from here.
Man, I thought I was going to be Depresso Espresso today. That was really great, Rachel. There's a cartoon as I'm pulling up my slide share here, a cartoon talking about, if one isn't talking in a meeting, their face is nevertheless sort of typing out the closed captioning. And my face, I shared it with all my friends because my face is certainly like that. I open book in many ways. And the idea of surveillance of my feelings on my face is kind of terrifying. So thanks to Rachel for terrifying me. And Tom, that was delightful. And I'm super excited about bioethics unicorns. And Mona, such a delight to be here. Thank you for the invitation. And thank you to all of you who are here in the audience. Spending your time with us is a choice, and I honor that. I also want to note that Dartmouth is on the ancestral and unceded lands of the Abenaki people. And our land acknowledgement feels particularly important to me, in part because Dartmouth was founded as an educational institution, at least its founding pitch was that it was an educational institution for Indigenous peoples. And there was a whole lot of theft and things went kind of south. we can talk about all that later, but it feels important to me to recognize both the sense of place, the ongoing caretaking by the Abenaki people of this place, and the continued existence of Indigenous peoples across the United States and North America more generally. My provocation thesis is essentially this. Vulnerability is a condition of possibility for AI and anatomy. And
Jackie,
I'm going to get into...
Sorry,
yeah.
we're not seeing slides in case you were working to share slides. We're seeing your browser window.
Oh, well, that is definitely not what I want you to see. So let's stop that share. And you get to see the role of the common carrier, it looks like.
Yes, exactly.
All right, let me fix that. Thank you so much, Mona, for letting me know. There we go. I believe I have it now. How's that? Yep. All right. Vulnerability is a condition of possibility for AI. I want to say, as I'm talking today, there will be a moment, it's the 4th slide in, I think, where I will be sharing some quotes from some history that I'm working on that is like wildly sexist and wildly ableist. And I'll sort of flag it before I get there, but if people just don't want to read that, that's okay. You can turn it off for a moment. I'll only read 1 or 2 of those. I don't need to dwell on all of them, but I wanted to give people that sort of heads up. Okay, so when I think of anatomy and AI, the very first thing that I think of is Sasha Costanza Chalk's excellent book, Design Justice, which came out in 2020. And this is an image from their book. It's in the very first chapter. And essentially what this image is doing is trying to both visually and then Sasha goes on to sort of narratively explicate for readers how millimeter wave detection works when you go to the airport, right? The airport security where you're asked to put your hands up above your head and stand there while the little machine scans you. And part of what Sasha is walking us through is this reality, right, that cisnormativity is built into the scanner software, right? And I'm going to read Sasha's own experience because I think they can speak it better than I can. Since my gender presentation is non-binary femme, usually the operator selects female, right? So as Sasha walks into the machine, one of the TSA agents either has to select male or female. However, the 3-dimensional contours of again, I'm reading Sasha's quote here. My body at millimeter resolution differs from the statistical norm of female bodies as understood by the data set and risk algorithm designed by the manufacturer of the millimeter wave scanner. Now, in this particular chapter, Sasha goes on to say, right, it's a literally no-win situation for them. If the operator selects male, their breast tissue falls outside the sort of statistical norm for someone that the software and the designers assumed was male. And if the operator selects female, then their pelvic region falls outside of the statistical norm. And the things that Sasha does extraordinarily well in this section is sort of give us a clear sense of how algorithmic design with algorithms and about a kind of binary vision of human anatomy comes to bear on a person in their everyday lived experience. For me, it's an incredibly powerful anecdote, and the book is available free and online if you care to go through and read that chapter. I really recommend it. The second thing that comes to mind is a piece that I co-wrote in 2019 for Slate titled "The Government is Using the Most Vulnerable People to Test Facial Recognition Software." And this piece I co-wrote with Os Keys and Nikki Stevens, who then went on to publish a peer-reviewed piece, Seeing Infrastructure, Race, Facial Recognition, and the Politics of Data. And in both of these, and in that work, part of what we as a group were excavating, and then Nikki and Os more deeply, was the way that NIST, which is the National Institute for Standards and Technology, it's a federal government agency, the way that NIST leverages particular kinds of images for training AI software. And it's important to note that this is training AI software not just by US corporations, so certainly in that kind of surveillance capitalism that Rachel was talking about, but also research universities. And it's actually open globally, right? So anyone, anywhere in the world who is either associated with a corporation, a research group, or a research institution engages with these challenges that NIST puts forward. And I've included on the bottom of this slide the sort of class under which this happens. It's NIST's facial recognition vendor test program. And on the right-hand side there is the Chexia face recognition and the FRVT 2013 are just two examples. They have a long list of various challenges that they issue. And the idea, right, is that they invite researchers to develop algorithmic tools that respond to their calls, and they award prizes, right? There's like monetary gain in addition to sort of, you know, the glory for a research product or something like that. But part of what our research showed is that the data set that NIST is offering to these researchers is deeply problematic, right? So the facial recognition vendor test includes materials that are held by the US government, which includes police and Homeland Security data. And that means that part of what we have is historical data for people from the very beginning of photographic mugshots of anyone who was arrested. So these are not people who have been tried and convicted of a crime, but anyone who was arrested, right? And we know that throughout the history of the United States, police activity has disproportionately impacted Brown and Black people, right? And so you actually have a overrepresentation of Brown and Black people in this data set, but of a particular, like with a particular orientation, right, of them as criminals. The Chexia face recognition set, the phrase "in the wild" came up, Rachel, in your presentation. And I don't think I'll ever be able to hear that phrase again after doing this work with Nikki and Os. One of the challenges of using mugshot data is that, right, everybody is in a kind of standard format, right, looking forward, a relatively clear orientation. And that's not how the, you know, the actual in the wild facial recognition deployments tend to work. And so they were looking for other kinds of data sets that would have people's faces, but in more challenging for the algorithm situations. And what they chose to turn to was a set of photographs used by people who were producing child pornography with people who, children who had been sex trafficked and or who had been, they were on like a missing list, right? So that people were looking, the police had their images, they often were scraping sort of dark web websites where the images of these children in sexually explicit and deeply violent situations, those were part of the police data set, and those then got rolled up into the Chexia face recognition project. So you've got people who are right, they're in trouble, and their children, and the families aren't consenting and the people aren't consenting. The third sort of major group that was contributing to this particular data set were people who were applying for US travel visas. So people who you know, wanted to be coming into the United States, had not in any way consented to their faces or their photographs being used in AI training, but nevertheless had been captured by the Department of Homeland Security. I also am one of the PIs on a project that is about the history of eugenic sterilization in the United States. We're calling it a contextual archive. And in this project, there's no machine learning, right? So part of what I'm doing here is going back in history. There's no machine learning, but that doesn't mean that we don't have algorithmic thinking. We instead have a kind of algorithmic thinking being performed by doctors. And here's where I'm going to turn to the quotes. Doctors under eugenics laws between the first part of the earliest decade of the 1900s up to the repeal of the last eugenic sterilization law in Oregon in 1983 were allowed by law to sterilize people based on essentially a kind of checklist, right? An algorithm that said, yes, they were appropriate candidates for sterilization. And some of these involved anatomical evaluations that are just kind of wild. 1935, 11 years old, the girl has menstruated and is physically developed beyond her years. We've got several instances here of people being, girls in particular, being overdeveloped, and many cases of physical deformity being discussed. I wanted to sort of pay attention to what's going on now in the use of, like I mentioned that I work on death certificates in preparing stuff for Mona. She mentioned that at the beginning. And people are looking to use death certificates now with AI for population health, demography, et cetera. And this quote is from this piece that's cited down here by Young et al. There's rich longitudinal health information from insurance claims, and those that have recorded death rates, that is vital statistics, are often separate, and linkage may be prohibitively expensive or prohibited because of data privacy restrictions. They go on to say that an algorithm, there are limitations, right? An algorithm developed in one population cannot necessarily be applied to different populations. And I think we've heard that in the previous two discussions. And they argue that what we need in order to be using AI in this kind of work is a deep understanding of the data and potential biases in the underlying mechanisms of data generation. We also need evaluation of algorithm performance across diverse subgroups and transparency in the dissemination of algorithmic inputs, parameters, and outputs. And I would say that I couldn't agree more, but I would also ask whether or not we have, if any of us, right, have the depth of knowledge and the positionality to be able to bring that deep understanding to bear. These are just a handful of the scholarly publications that have come out on algorithmic bias. And for those working in AI and anatomy from like anatomical science, I'm not sure that these are the kinds of texts that they are deeply reading alongside the other work that they're doing. Thank you.
Very, very many thanks to Tom, Rachel, and Jackie for these extremely insightful presentations. There's so much in here, and I have many questions. So I'm going to take chair's privilege and start us off with a round of questions. This is also a call for our audience members to put your questions into the Q&A box at the bottom of your screen, and we'll begin to fold those into our conversation. Tom, I'm going to start with you. I am so curious to hear how AI is being sold to folks who teach anatomy. What is the promise that is being made to educators? Can you tell us a little bit more about that?
Sure. So the promise is twofold. One of them, of course, is economic. It's much cheaper to buy a computer with a great screen, et cetera, than it is to actually work with a human body donor and go through the whole process, et cetera, et cetera. So there's this economic aspect to it. That tends to be put on the down low, but it's certainly there. And they will let you know that it's going to be less expensive. And deans love to hear that, of course. The educational phrasing they give is that it will allow for a more varied educational experience. That AI could allow you to, do virtual reality, could allow you to see things from a different perspective. But what they don't provide is any of the human, emotional, and psychological and developmental components that come along with learning. They are strictly saying, we'll be able to teach you the muscles of the hand in a different way than the way you've learned the muscles of the hand on the body, right? And I could even debate that it might be better to learn the muscles of the hand on the body than it would be to learn in this virtual or AI type world. But that's pretty much the way they approach it. They approach it strictly from a body parts phenomenon, that we can teach body parts from a different way or a different look, which, as Jackie has said and others, it relies on bias. You're not getting a full data set of human individuals with all their variations, et cetera. It's generally not as good resolution. Even the best AI systems have very bad resolution for very small anatomical details. So there's a lot of problems with it, but it's new and shiny, and people think, ooh, you know, it's got bells and whistles, and so it has its day. But I think most of the old anatomists at least realize the value of actually working with these individuals and learning from them, as opposed to, as I said, you can use the AI stuff as enhancement to the education, but it should not be the basis for your actual education.
Thank you, Tom. That was very helpful. And I had no idea. So I learned a new thing here. And I'm inviting the panelists to chime in here as well. Jackie, do you want to?
Yeah, I was just going to note that economic logic has been there in the history of processing mortality records from the not the very beginning, but in the mid 1950s, 1960s. The US put a bunch of money into computational approaches to coding death certificates. And that was a science of nosology. They thought they were going to save money by replacing the human nosologists who coded the death data. And it turns out they didn't save money. It didn't get faster. The only thing you got was more data.
And I will point out, the economic aspects are there even in the non-anatomical world. So you probably have all heard of the NBC investigation on the unclaimed in Texas. That was an economic driver. Those were counties in Texas that wanted to save money by not having to deal with their unclaimed individuals. And so they gave them to the University of North Texas, which the University of North Texas then sold them for use in other places and made money off of those individuals as well. So behind all of this AI stuff we hear, there is definitely economic issues that are involved.
Thank you both for that. Rachel, I'm going to take this as a cue for you, because you spoke about this through the framework and the work of Zuboff, of course, surveillance capitalism. So can you say a little bit more about the relationship you described between physical features and movements and the inner self, the inner human experience, and the sort of capitalist, as Shoshana Zuboff will put it, ways of extracting this as data to predict behavioral futures? It seems that these are connected, what Tom and Jackie just explained and what you brought up in your conversation.
I mean, I think so. Already a whole lot of what we do digitally is collected as you search for X, we're going to use that search. How many of you had the eerie experience? You're looking for a pair of shoes and suddenly you get all of 10,000 ads. And that's been going on for a while. And it's the way that Facebook and Google are actually making money for using you, in Zuboff's words, as raw material. And I think that gathering facial stuff, and again, this is the speculative part of this. These are now being used for research. How can we typologize facial expressions to come up with some kind of a way to measure different kinds of mental illness, different kinds of expressions? What do they mean? And I think that the tricky part is that these things, once you've got your typology, once these technologies are better, why not embed it in your browser? Why not put it, and I think the initial uses will all be in mental health. You guys have probably heard ads for things like BetterHelp, which is like online therapy thing. It's you find your therapist anywhere, anyhow. Allegedly, it doesn't work very well because there's too many people needing therapy and not enough therapists, and the therapists aren't getting paid. But the idea is to, disrupt therapy. And I think that all of these chatbots, you think about organizations like the NHS are using them to make therapy cheaper, to sort of replace the human element, which is we come back to that cost thing that Tom is talking about. But I think that there's that you could imagine, as I said, the kinds of employers who are already surveilling their employees in different ways. They can't, by law, access things like, even if you're talking with a chatbot, HIPAA is still going to sort of say, yeah, no. But looking at a face of your employee as they walk through the door or while they're working at their computer or whatever, I don't know what the legality of that is. And I suspect it's probably fine until it's not. But what can you predict? What kinds of behaviors? Yeah, to give an example that I thought of, people who are manic depressive, when they hit that manic phase, are often will buy a lot of stuff. Could the system actually sort of predict, oh, well, they're about to go manic. Good. Let's throw a bunch of ads their way. Now, that's deeply cynical, but there may well be other kinds of, or maybe not cynical enough, I don't know. But there may be other ways that you can use the understanding of emotional states. You can certainly imagine police or government organizations, interrogations and what is this person reacting to, and you're in the realm of whatever the TV shows where the person could see if you're lying or not. And so, but you also have the kinds of problems that Jackie's talking about, that there are issues of, you know, cultural difference or individual variation or all kinds of ways in which people likely won't fit the model that gets put together. And that could have insurance repercussions. Can you actually get your prescription if your facial features don't do the work of saying, yeah, she's definitely depressed? So I could see a whole range of ways that these kind of technologies, which now are really being done with I think noble intentions of better understanding depression. Um, but it's it's open source software. So anybody could pick it up and tweak it, and it could be used for whatever. So I don't know if that quite answers your question, but
So I have a follow-on that. What about some really good actors who are going on stage and acting depressed? Right, their faces are going to look depressed. But they're not actually depressed. So there's a lot of people out there that can act really well, and I am curious about how an AI is going to discriminate between somebody who's acting depressed or acting happy versus someone who's really depressed or really happy. And then you have the psychopath or the sociopath who never looks bad at all, but is doing all sorts of bad things in the background. So there's a lot of limitations that I have concerns about.
well, and you could imagine that you might want to test for sociopathy or psychopathology, but there might be people who just are part of that normal variation who just aren't super expressive. And those people suddenly the labels happen that fast.
Thank
So
you so much. Sorry.
no, go ahead.
Thank you so much for that. I am, Rachel, you've done work on uh, anatomical education and how to teach that stuff. So from your sort of social science point of view, how do you see these developments vis-a-vis what Tom has described earlier, where there is sort of a it's the new shiny thing, right? But then also we know AI really is also used to automate or semi-automate some of the logistical, administrative things that we as educators all have to do. Can you speak to that a
Well,
little bit?
a little bit. I mean, Tom, I'm curious. When I was, I haven't been back in a bit, but when I was studying anatomy labs, the virtual tools were coming online. But then when I went back after a few years, and they probably would look primitive now that we're like however many generations of stuff further on. But one of the things that was starting to happen was physicians, people in med school were getting taught with cadavers, with donor bodies. But people like nurses, physical therapists, occupational therapists, that had all gone virtual. So there are people who weren't getting the benefit of that, the emotional experience, the close thing. And I'm assuming that's only accelerated that ish.
I don't know. So it's been interesting. I think there's been a little bit of pushback. There was kind of a phase of, ooh, we're going to go technological. And then they see the technology doesn't really do everything they want it to do. And there's a little bit of flow back the other way. So interestingly enough, here at University of Miami, our physical therapists do a deeper anatomical experience with the donors in the lab than our medical students do. So it really is dependent on the university, the professors involved. I think there is this shiny new thing that comes up, but then it tends to loses its gleam after a while, and people tend to go back to the standard that always has and does work well. So I don't think it's necessarily a progression up, continual progression up.
Yeah. I think your point that this is very attractive to deans, that's been around for a while, that some of the background is that donor programs are very expensive. It's hard to do. And so all of those digital shiny things look cheaper. Now, do you have to buy the update? Do you have to, on and on? They may not be as cheap as they appear to be. But
and not as valuable.
Yeah, exactly. And then you ask what the quality of the educational experience is.
Correct. And what you're trying to teach, right?
Yeah.
What are you trying to get across in the lab? Yeah.
Apropos.
And I'll go back to Jackie's point about bias. Actually, one of the things we try to teach is all the variability that occurs in the human race. I have these really great pictures of all the different colors of humans, right? And all the different sizes and morphologies of normal humans, because that's one of the things we want to really emphasize, is that we're not all built like me, right? There's this wide variety of human variation and human diversity. And we want to emphasize that, not de-emphasize that. And I think AI somewhat flips that script and tries to normalize everything as opposed to allowing that wide variance to occur.
And that is a great cue, Jackie. So you so well demonstrated how normative assumptions around bodies are deeply problematic, are deeply entangled with the history of eugenics, and how this legacy still shores up not only in technologies that we use today, but in the way in which we talk about them and how we imagine them. So I'm wondering, speaking about education, how do you see, or what future would you envision in which these relationships can be made more explicit? Not just in education. We talk a lot about how we need to make computer science, information science, data science, AI education more quote unquote ethical and all of those things. And that's an important discourse that's been going on for a while, but how it seems that things are a lot more entrenched, right? All three of you are showing that there's a long history. So how can this be really, for the lack of a better word, excavated better in the public discourse?
That's a great question. So there's a lot to be said. There's the frame of computational tools, whether they're algorithmic or not, being black boxed, right? Stuck in a box that you can't see inside of. And so far as I can tell, even folks who are pretty savvy with algorithmic auditing are finding it incredibly difficult to audit algorithms, right? And I think, there's a way that some of it's incredibly boring, right? Like talking about how software is built, right? Or how like an algorithm is created, and then how it's manifest in software, how a data set is created, and then how that data set underlies the software development. They're kind of boring tasks, right? In some ways, it's paperwork. It's paperwork, and then it's code work. And it happens over long periods of time, and it happens across multiple people, right? So in my last slide, one of the book covers that I showed is Dan Book's How Our Days Became Numbered. And he has this amazing ability to make the process of gathering the census like come alive. He's an incredibly gifted writer. I love him. right? But there aren't very many people who can make a census exciting, right? But he does. And that process of going like door to door and talking to people and writing people down, in a in a giant spreadsheet, is mind numbing to most people. And so I think we have to come up with some way of telling the stories of how the data sets come to be, and how those data sets then roll up into software, and how those software tools roll up into our everyday experiences. We've got to find some way of telling those stories better. I don't know that I have the answer, really at all. Actually, I think, I'm personally interested in writing for a public audience as opposed to an academic audience, in part for this very reason, right? That I think the average person, who is not a researcher in an academic institution, doesn't necessarily have this information at hand. So I think some of it's about storytelling. I think, I because I like getting my I really like working with my hands, right? And I think Tom's observation, right, that you can't know human anatomy until you've sort of had your hands in human anatomy. I was a molecular biology major as an undergraduate, and like anatomy was my favorite class. But the getting our hands on the real thing, whether that be the algorithm or the software or the data or the body, strikes me as deeply important, right? If we simply receive data sets to use, rather than build them ourselves, I think we have a real problem. I think if we simply receive, whether it's the body world's plastinization bodies, or it's a virtual slice in a 3D software of a body, if we just receive that, I don't think we have the same sort of cognitive connection. And I don't think we have the same kind of embodied connection, right? I believe really strongly in embodied knowledge. And so, I think there was a reason the early modern period, people were out grave robbing. People were grave robbing all the way up into the 19th century in order to get their hands on human bodies, because they were using proxies that were animals, right? Pigs, horses, cows. And it was like, it wasn't working, right? Reading in a book, it just like, it wasn't the same. And so people were digging up their fellow people in order to be able to do this. And I think there's a reason why. I'm certainly not saying that we go do that, but I am saying that I think embodied knowledge is super critical, which means that we have to be in contact with others. And I think storytelling is going to be really important, even if it's about the most boring things, right? Turning people into paperwork or giant spreadsheets.
I can flip that to the extent of the practical aspects of it. What we do in our lab. For instance, we do not have any technology in our lab. We have the donors, we have some plastic models, but basically we have the donors and the students. And when we bring the students in, we introduce them to the donors and we talk to them as if they're patients. We actually let the donors provide us with voluntary information. They'll give us a little biography and some pictures, and we put those on the donor tank so the students can realize that these were living human individuals and what their lives were like. We try to emphasize that this is the value that you're learning here. That no technology is going to give you that same impact, that same emotional reaction, that's the things that are going on. And we explicitly think about that and work on that, right? That this is an important component to the parts of the things we're teaching, not just the body parts, but the actual things we're teaching. And so I think, Mona, from our perspective, we're trying to do it on the ground for the people that we are actually working with, right? For them to realize why we're not having all this gee whiz bang AI stuff going on. And I think we're trying to do it one student at a time, with the people that we're impacting, and trying to let them see that they're going to be working on real humans in the future. They need to know how to work on real humans now, and to bring that connection together, that human element, like I said. So,
Rachel, you're muted.
If I could add something to that, a lot of my work has been about a kind of comparative space of what can be made algorithmic about human experience or human lives or human bodies and what really kind of can't. And I think that Tom is exactly pointing to one of those places, my experiences both of being in anatomy labs and of doing a little bit of dissection. There is certainly, intellectual things, but the emotional experience is kind of profound. And I'm not a physician, so I don't know how it shapes clinical practice other than from talking to people who, one of the surgeons I worked with used to say that she finds doing surgery far less disturbing than dissecting cadavers because the cadaver, the soul is gone. And she feels like it's a different kind of violation. So there's parts of human experience, and I think that's part of what I'm trying to point to that maybe can't be captured by whether it's motion tracking or whatever, but also maybe shouldn't. And those are the kinds of things that I think that it's kind of an ethical question, not in the sort of Kantian bioethics stuff that we teach, but it's a sort of a deeper question about how much do we want to give of human experience to kind of machine algorithms that don't get, whether it's body variation like Jackie's talking about, or anatomical variation like Tom is talking about, or parts of your inner life. So I think that that's a question that we are our asking it is behind, in a sense, the development of the technology. It's not really actually ahead. We've been anticipating cloning forever and talking about it, but this kind of stuff is not actually as fleshed out.
That's so great. The sort of continued moment of anticipation, right? That goes with all of this stuff. I'm going to start bringing in our audience questions. And so, Jackie, I'm going to start with you. This is from Emmanuel Moss, and he's saying it seems like so many of the problems of algorithmic approaches to anatomy come from how they tend to confirm received notions about bodies, emotions, and how bodies have been categorized. All of you have spoken to this. Are there ways to challenge or push back on some of these received notions with the same tools? Can algorithmic approaches help debunk scientific racism? Jackie, this one's for you.
Yeah. So let's see. I'm going to set aside the debunking question first. Certainly pushing back, I think, is a possibility, right? I think of like Joy Buolamwini's work, right, in the Algorithmic Justice League, thinking about sort of how AI can be leveraged to assist those who have been harmed by institutional racism in medicine. And for those of you who don't know Dr. Buolamwini's work, one of the things that she was working on when she first started publishing was cancer detection in African American people, right? And so the kinds of computer vision, right, that was being used for typology of lesions wasn't working as effectively on skin that was more heavily melanated. And so I think there's a way in which that's a kind of pushback, right? Black women in the history of medicine have been used as sort of exploratory subjects in a number of really horrific ways, but those have never been to aid them, right? And I think there's a way in which Joy's work on lesion detection in skin cancer is really powerful. I think also about there's a discussion around not detecting, but noticing domestic violence on darker skinned women, right? That bruising shows up differently on darker skinned bodies than it does on lighter skinned bodies. And so there's a range of sort of first response medical professionals who miss bruising in darker skinned women. And that there are ways in which one might be able to, in a space where there aren't as many people coming into an ER or people haven't been trained on a diverse population, right? There might be ways that one could use computational models, right, to help provide some of that experience. I think debunking, I, I don't know if AI can debunk scientific racism, in part because it feels to me like a little bit of the master's tools, master's house kind of problem, right? Like, I think AI is so deeply imbricated in the history of scientific racism that I'm not sure that I would want to use it to debunk that particular thought tradition, right? I think we have lots and lots of ways to debunk that thought tradition that don't require us to use AI. That isn't to say that we can't use AI, right, to do better, but I don't know that we can debunk scientific racism with AI.
Thank you for that. It's interesting how it's a chicken and egg kind of question almost, right? Rachel, I have one for you. And this one is from Andre Sobral, who is saying, is it likely that AI applied to diagnostics or predictions could lead to recursive and normatizing effects? We spoke about that a little bit. As AI is implemented, patients may begin to emulate the symptoms or conditions that the AI is trained to identify, creating a conflict between the AI and the public. Each iteration of the training database frames disease in a way that could reduce costs for insurers, but this might also lead to distorted perceptions of diseases as patients adapt to the AI's focus. How do you see this dynamic affecting both medical practice and societal understanding of health? The reason why I have that question is because it's what you said, but also we could think about this not just in terms of medical practice and patients, but also employees and employers, right? Over to you.
So one of the reasons in this mental health world why this question of positive or negative expressions of affect might be misleading is that there's some belief that it's entirely possible that depressed people are smiling more because they're actually sort of trying to put a good face on it. So it's again this it's so they're already in a sense conforming to not so much to what the machine is asking for, but to what they expect people want from them. And so that's where those kinds of expressions are, not always, not necessarily reflective of the inner state. And whether people would sort of conform to the technology itself and to the way it measures, one of the I think reasons, one of the reasons why people always want the objective test, the blood test for depression or whatever, is there's a lot of mistrust about patient statements. So if a patient says, I've been feeling depressed, it's like, one of the words I'd like to sort of ban from the English language is malingering. Oh, you've had this tick bite and now you feel terrible for years on end. You must be malingering. Well, maybe not, but that's a mistrust of patient statements about what's going on with them. And so I think that the assumption that from external behavioral characteristics you can get people, you can actually figure out what's really going on with people may be flawed. But I think also that I think behind the question there's this concern with whether people might learn to game the system, which is possible. But also I think with whether we might find ourselves if the system is sort of, if the modification part of the system is sort of asking for certain things, what's it asking for? Is it asking for us like, there are sometimes good reasons why people are depressed. You have one of my Joe Dumet, who was one of my dissertation committee members, has written about after 9/11, pharma companies were like, well, if you're feeling bad for more than say a week, maybe you should medicate. And he's like, maybe we should just be angry at what's happening in the world. So the questions of what is the goal of this kind of analysis? What are people trying to do? If it's, oh, you have a lousy afternoon, I'm assuming these systems aren't going to say, okay, go check, call, ask your doctor if you need whatever. But you could see moving that direction. And so I think that there's always this conversation between the patients or the people and the technology. And will people come to see short-term short-term lows as something that's dangerous or medicatable or otherwise problematic? I think is highly possible and possibly desired by the kind of people who want to sell you meds. I'll stop there.
Yeah, Jackie, and then I have a last question for Tom before I close this out.
Yeah, I just wanted to add on there that I think there's I don't know if other people have had this experience of going to the doctor and they're typing as they're going, right? And you're telling them the things that you're experiencing. But I know when I do that, I trust that doctor less, right? Because I want them to turn around and pay attention to me and what I'm saying to them. And I often see them sort of say, okay, well, what about this, right? Like the computer is prompting them, right, to say, well, check for this thing, or oh, check for this thing. And I absolutely will confess to, like, saying the set of things that I think the computational brain wants to hear so that I can get the doctor to listen to me, right? And so I do think there is a feedback loop there, especially as someone, right, who, historically physicians aren't great at listening to, right? I think there's a way in which we do modulate ourselves in order to achieve the ends that we're looking for. And I think Rachel's point is right, that's a really complicated space. And it's now also being intersected with insurance companies, with employers, and with people who want to sell us stuff. And that makes it even more complicated than it was prior.
Thank you for that. And it speaks to the sort of layering of incentives, technologies, histories, some of which are, of course, deeply problematic. Tom, Janine Denoves has a question that I would like to ask you as the last question today. And they say one of the things we know about trauma and harm processing is that it requires somatic therapies and interventions, meaning people connected to their bodies and making sense of those bodies, as you also described in your lab in a way. Can you say a bit more about your thoughts on the impact of these technologies on our collective ability as a society to process and heal?
So I guess I'll start with a story in some ways. It's kind of nice to do. One of the things we found in the old anatomy lab when we were teaching anatomy, I've been teaching anatomy all the time. 40 years ago, when we were teaching anatomy, we taught anatomy that we were just teaching anatomy. And we said, you're just learning the muscles and the bones here. We're not going to teach you anything clinical. Don't think about this individual that you're working on. This is just a tool or an object that you're learning anatomy from. This was all to produce a physician who would have what we called clinical detachment, right? That they would be detached from their patients and be able to rationalize and work well with their patients without letting emotion get in the way, right? And we've now decided that probably went too far. We were probably making those doctors more like robots, right? With no emotion and just cognitive ability to work their algorithms, whatever their algorithms are going on in their cortex, to figure out what was wrong with those patients, right? And to this day, some doctors still don't talk about a patient, they talk about a diabetic, or they talk about the cancer. They talk about the disease and not the patient. And so we're changing that idea to try to teach these upcoming doctors that those are individuals in the lab, that they had lives. We're trying to not have that same level of clinical detachment, that same level of emotional detachment that would take place. And I think there's a parallel there with using AI, that AI in some ways allows those people studying it to do more clinical detachment, more emotional detachment. You don't get emotionally attached to your computer, you get emotionally attached to individuals. And I think no matter how good an AI is, it's going to have a different level of, you're going to have a different level of interaction and a different level of attachment to it. And I think that's why there is always that limitation. No matter how good it's going to be, that limitation is always there. And that means that you're not going to get as good an education. You're not going to produce as good a physician if you only use electronic means for that educational experience. And that there is this ability to interact with the actual human, both in the lab and in the clinic. You know, that's the really important, as I say, human element that is necessary in anatomy and in medical education.
Thanks, Tom. Rachel, before I close us out.
I'll keep it brief. I think one of the other problems with the sort of rise of algorithmic thinking is it encourages that kind of thinking when people ought to be looking at or thinking about, sort of using common sense, which is something that's sort of, I think, a little bit anemic lately. And I think about this like with my undergrads who really want a form to fill out. They want the rubric for everything, rather than actually thinking their way through a paper. But I also saw it in medical schools where you've got like grading scales for severity of an illness. And you say, okay, if the patient is at a grade 4, do you operate? I actually witnessed this in a rounds presentation. And the student says, well, yeah. And the doctor says, sorry, person's too sick with their grade 4. But that student wanted to say, well, grade 4 equals more severe, therefore we should operate. And they wanted to sort of use that kind of grade to sort of determine what happens. And I think that kind of thinking is can be useful sometimes with things like checklists, make sure you get every step done, but can also kind of have you forget. And I think this is part of what Tom has been stressing, that people can sometimes forget what they have to look at are the unique circumstances of that person or of that problem or of that paper. And that's the kind of thing that isn't necessarily going to fit in your rubric or checkbox or whatever.
And we could argue that that's what makes us social beings. And I'm going to take that note as a cue to thank my wonderful panelists today, Jackie Warnemont, Tom Champney, and Rachel Prentice today. Thank you for your really insightful contributions on the topic of AI and anatomy. Lots of food for thought, certainly on my end, and I know a couple of folks who will certainly bring this into their classrooms as well. Jackie, Tom, and Rachel are online. They're doing wonderful scholarship and public scholarship. You can find them and reach out to them and read their terrific work. We will be back for the last Co-opting AI event in 2024 on December 4th, and we will be talking about cars. Mobility has long been entangled with dreams of artificial intelligence, and we'll be talking about that with Melissa Chafkin, MC Farrell, and Nathaniel Chodosh on December 4th, 4 p.m. Eastern Time. We hope to see you there. Thank you all so much for your time today, our panelists, audience members, and our teams. Thank you, and have a wonderful evening. Take care.
Thank you.